Hello friends, welcome to the video number 4 in the series of building the massively printed CNC machine. In the previous videos we did assemble the frame and the middle section. In this video I'm going to combine the middle section with the frame, and later I will mount the motors and put the belt, and by that we will finishing the frame build. After that, in maybe the video number 5, we will go through the electronics and the firmware. First, I'm going to put the middle section on the frame. Try to make the rulers in the middle. And when you are going to put the middle section, as we mentioned before, notice that the tool mount must be face the corner you had planned to put in. My zero corner will be in this side, so this is how it should be. As we said, the tool mount is facing the zero corner, as the end stops are facing too. And now to fix the tubes, we are going to use the motor mount. The motor mount will come on the top of the ruler, and there is two pockets. I'm going to bring the camera. As you see, there is two pockets to put the M4 nut inside them. Because of the plastic lock, it's not fit very well. I did remove the bottom section in the plastic lock, so it now stay in place better way. It's hard to work in one hand, so I'm going to do the process for putting the M4 nut in place and try to align the hole of the nut with the hole of the ruler. Later, as we said, we are going to mount the motor mount on top of them. pay attention to the direction of the fiber. I did put down those earlier, so now we finished that. I'm going to mount the motor mount. I'm hearing cracking sound, but I didn't tighten them too much, as I hope. To assemble the motors with the motor mount, we need 4 10mm M3 screws for each motor. When you are going to mount the motor, pay attention to where are the wire of the motors are going out. For better wire management later, find the right side for that. I think starting with the bottom one, it is better. Just to be sure that it is catching the thread of the motor. I'm not doing it to the end, just as I said that there is no space between the motor and the plastic. No need to over tighten the bolts. For the pulley, when you are going to put them, if the shaft of the motor have a flat side, try to get one of the screws of the pulley to go on that flat side. And if you are using the 6mm belt, the pulley will go in this direction. So because the belt it will be near the plastic, so the pulley will be like this. But for me, because the pulley for the 10mm belt, when I'm putting it in this position, the screws are not catching the shaft. The shaft is short, so I'm going to put the pulley in this position, and by doing this, the pulley have this space, so without the spacer, the bearing was going near the plastic and there will be some misalignment in the belt. So I did give the spacer a height as a same space for this part of the pulley, and now the pulley and the bearing are doing better alignment. As we said, start by tightening the screw on the flat side of the shaft. We are going to do the alignment later when we will put the belt. That's it for the motor and the pulley. Repeat the process for the remaining motors and pulleys. Now for the belt, as a standard assembly, when you are going to use the 6mm belt, you will need the belt and the cable zip ties. Hold the belt so the teeth are facing down and insert it under the first bearing, over the pulley, and down under the second bearing. Make a loop in the tip of the belt and use one cable tie. To make a knot, try to make the belt flat as much as possible, and if necessary you can add another cable tie. Cut the extra part. Now take a new cable tie, insert it to the nut and into the hole in the bump of the corner part, and close the cable tie. Make sure that the lock piece is facing the flat side of the bump in the corner part for making the calibration and adjusting the tension of the belt later. If you are going to use a longer zip tie, so you have more space to do the calibration. Don't cut the extra part to make it easy for you when you are going to do the tensioning. Now you are going to do the same in the other side of the corner. For me, I did some modification and designed a belt tensioning mechanism, a simple one. I'm going to show you that. Because I want this bump to be longer to fit the space I did made by putting the spacer according to this part of the pulley. So I did design this part. I'm using 3D Max as a CAD program. I scaled the original part and cut this bump from it, and later subtract the original part from this one, and got the perfect hole to fit the knob inside it. As you see, it just came as a cup for that. And for the tensioning, I didn't want to use the cable tie as a whole tensioning mechanism. I did came with this one. It's just a simple design using an M3 bolt with 40 millimeter long, just putting in the hole, and by tightening the nut of the M3 bolt, I will do the required tension in the belt. And for attaching the belt to the mechanism, just as before, I'm going to put it like this by using the cable tie. As you see, I think this will be better than the first method. I don't know, we will see later. Of course, for the other side of the axis, I didn't want to use the same part and the same mechanism. I'm going just to use this. It is a mirror from this cup, attached this part to it and printed them together, because you need to make the tension calibration just in one side. And for this part, when I printed it the first time, I printed it like this, so there was no chance to put the bolt inside it. Later I redesigned it and make it two parts, made some simple male-female channel for better fixing. So I just put the bolt, put a drop of super glue on this and press them to stick together. Also, as you can see, because I'm afraid that it will open when I'm going to tighten the belt. So as a precaution, I just tighten one cable tie on this side. This side no need to put a cable tie to it because the belt is already catching it. So I'm going to do this knot on the opposite side of this axis and do all the belt as well. Also, I want to mention that the top corner and the bottom corner have a different part for them, because this is longer than let me show you. Because this bump is longer than the bottom one, so this is for that, the mirror one. And of course in the other side will be this. So this is what we have. Also later, when I'm sure that it works perfectly, I did this hole to put a screw and fix it, or maybe drop some super glue and fix it in place. Now for the tightening and calibration, there is no specific scale for that. Just try to keep the both belt in each axis have the same amount of tension. It is just that the belt is not slip over the pulley's teeth, and also not very tightened that the motor will not move. Also try to keep the tensioning mechanism of the both belt for each axis in the same side of the machine. For me, the X-axis tensioning mechanism for both belt was for the left of the machine, and the Y-axis, the both belt mechanism are in the front. And for the tightening, for my design, just by hand tighten the belt, and with the other hand just tighten the nut of the bolt. You can do the belt tightening just by rotating the nut of the screws also. In the next video we are going to do the electronics and the firmware and do the basic wiring for the machine. This was the building of the massively printed CNC machine. We assembled all the parts together and I really enjoyed it. I hope you also enjoyed watching the process. If you have any comments, please leave it in the comment section. If you didn't subscribe yet, please subscribe. Hit the bell button to get notified for the next videos. Please, if you like the video and the series, share with your friends. That was the end of the building. Thank you for watching. See you in the next video. Goodbye.